HVI's VLF E-Series are advanced VLF or very low-frequency AC high pots used for the testing of high-voltage cables in motors or generators. Common testing standards that the VLF E-Series support include IEEE 400.2 2013, IEEE 400, IEC 660-3, Senelec HD 620, 621, IEEE 433, 2014 for motors or generators, and many other local standards. The VLF E-Series feature an LCD display screen, button and dial controls, and an antenna setup for remote operation through our E-Link software. It supports an optional but useful tan delta bridge to expand testing capabilities. All along the way, intuitive and user-friendly menus are built into the HiPod. The E-Series is designed to test, save, and export results for VLF high-voltage tests. Typically withstand or maintenance tests for medium to high-voltage power cables. They provide a high degree of accuracy for measuring voltage, current, capacitance, and other parameters. Electrical testing professionals can test directly from a manual mode, or create predefined testing profiles or sequences. The VLF E-Series are designed and built with multiple safety provisions in order to protect personnel and equipment. They're housed within their own rugged storage for years of use. HVI is proud to offer a reliable, sturdy, and highly mobile series of VLF testing units that are used all over the world. In this video, we will review the control and display features of the VLF E-Series and its basic menu operation. We'll show you how to create a test profile or sequence from the menu system, how to set up a test, and finally, how to run one from local control with the front panel. A separate video will cover the use of the E-Link software and remote operation of the HiPod. Please note, the VLF E-Series comes in two sizes and kV capability. The 34E, capable of 34 kV peak, and the 65E, capable of 65 kV peak. The menu screen operation and many other display and control features are the same between the two sizes. However, the 34E and the 65E have slight differences in output cables and where certain elements are physically housed. For the purposes of this video, we will be depicting a VLF 34E. Please note, the general operation of a 65E unit will be much the same, but specific differences may emerge. Refer to the user manual as necessary. Overview. The VLF E-Series have a universal input power supply located within the left side housing compartment, one of the two main compartments built into the case. It accepts most standard 3-prong electrical cords. The main power switch is located above the 3-prong connection. In the upper right, there is a light tree and external interlock safety provisions. Always consult and follow your local and workplace safety standards. Below the light tree circuitry is a standard USB connection for firmware updates. When powered on, the high voltage status light for off should illuminate in green, and the main menu screen should now be lit and visible. The high voltage status light continually indicate to operators the current status of high voltage circuitry and capabilities within the device. Green for off indicates the device is on, menus operable, but no high voltage circuitry has been enabled, or that the voltage on the device under test, or DUT, is less than 200 volts. When the yellow, or enabled light illuminates, it means that high voltage will be soon generated. A red light indicates high voltage is present. follow all local and workplace safety standards. Immediately below the high voltage status lights is an external safety key. Only when the key is in the interlock and switched to on can high voltage be generated. At any time, if the safety key is switched off or removed, the high voltage circuitry shuts down for the safety of personnel and equipment. Another important safety provision is the one-push disable button. At any time, if the disable button is pressed, it will shut down high voltage generation. The digital display is in the middle of the top panel and accompanied with 4 selection buttons and a rotary encoder. On the bottom left is a USB port that accepts thumb drives for saving and exporting test results to outside computers. Best practices for the VLF E-Series are to transfer saved test results semi-regularly. While there's built-in memory storage, the storage is not infinite, and tests will not overwrite prior saved files when capacity is exceeded. Finally, the VLF E-Series have high-voltage output and ground lead connections. These are housed within the right-hand side compartment case. During a later section of the video, we'll show how to properly set up and connect the high-voltage output and ground lead to these connections. Menu operation. Operation of a VLF E-Series is based on a standard structure of menus and submenus, all of which can be controlled with bordering buttons and the rotary encoder. In the main menu, there are 4 major functions to choose from. The first is Last Test Setup. This allows users to automatically run a defined test profile or sequence, specifically the last one used on the device. For many electrical testing professionals who use a small range of consistent tests, this is a useful feature. The second option from the main menu is Saved Test Setup. This allows users to choose, view, or edit a predefined and saved test profile or sequence. Many test profiles can be stored and used again later. The third option from the main menu is New Test Setup. From here, users can operate from manual mode to run high-voltage tests on devices under test. Manual mode is the only mode that lets testing professionals adjust testing parameters after a test has begun. Users can customize along many different parameters. These include waveform, frequency, fault detection response, number of steps, the voltage applied per step, and the duration per step. The fourth and final option from the main menu is Advanced Settings. From here, users can fully create, view, edit, or rename saved testing profiles and sequences. All saved files on the device can be copied, moved, or deleted. The advanced settings also control date and time settings and formatting. All tests are time-stamped, so proper date formatting is important. The advanced settings also control the units displayed for voltage, RMS or peak voltage. Advanced settings also display the current measurement source and have a PAN ID selector for connecting to E-Link software and to external devices such as a TAN Delta bridge. Finally, advanced settings is where your firmware version is displayed. Creating test profiles and sequences. In this section, we'll show you how to create test profiles and sequences. As a hypothetical example, we'll create and name a test for the maintenance of a 15 kV cable, according to the IEEE 400.2 2013 standard. With your device on, first, press Advanced. Select Profile. Select New. Save the name and press Done when the name is correctly entered. Now it's time to choose the parameters of the test. First, choose your waveform type from sine, square, or DC positive or negative. We'll choose sine wave. Now, set your frequency in Hertz. Conventionally, we'd test at the highest possible frequency, at 0.1 Hertz. However, slower frequencies down to 0.01 Hertz are included for the testing of higher capacitance loads, such as longer cable lengths. We'll set ours at 0.1 Hertz for now. After you've set the frequency, select your fault detection mode. With the overload on arc setting, when a fault is detected, the high voltage circuitry shuts down and the test is stopped. No more voltage or current are supplied to the device under test. With Burn on Arc mode, you can further burn and condition the fault for easier detection with other common cable fault location equipment. This should be used for troubleshooting purposes only. We will choose Overload on Arc, our default mode. The next parameter is Step Selection. VLF E-Series are programmable up to 5 steps. Some tests may require just a single step of testing. Others, such as a tan delta test, require 3. By default, our first step is Step 1. Should we add extra steps, we come back to this menu and choose a second or a third step. The other parameters won't automatically clear, but they become editable again. You can then change parameters such as voltage or time by using the same controls as earlier. The next selection is voltage. Voltage is displayed in either RMS or peak units. It's important to know which units are chosen. Users can select between RMS and peak in the advanced settings. For example, we'll choose 16 kV RMS here, the appropriate voltage for the maintenance of a 15 kV cable. There are also decimal units for the voltage. You can add or select voltage to the 10th of a kV. We'll keep our voltage at 16 kV RMS. The next parameter is duration. Here, you set the duration for this step in the test profile. You can see our increments go all the way up to an hour. We'll choose 30 minutes. At this point, if there are additional steps for the test profile, use the main dial control to move back to step. Choose Step. Scroll down to 2 and select 2. Then set the voltage and duration required for Step 2. Repeat the process for Steps 3, 4, and 5 as needed. The last fields on the test profile creation are optional. With phase, location, and circuit ID fields, users can identify the devices under test or sections of a workplace they were working within. When all the parameters and fields needed have been properly set, select the Done button. The test profile is now complete and saved. It will now be available under the Saved Test Setup section of the main menu. Setting up for a test. Always follow all local safety protocols in your workplace. Find a location that allows for easy view of the control panel and display screens, and offers proper space distance from the DUT. Make sure that all controls are off. Open the left side compartment and connect the main 3-prong power cable to the main power connection. Plug the main power cable into a grounded power source. Open the right-hand side compartment and connect the green-yellow ground lead to the ground stud using the forked prong end. Once the ground return lead has been connected to the high pot, extend the lead toward the cable being tested and use the alligator clamp to connect to the shield of the cable. After the ground lead has been connected from the high pot to the cable, it's time to connect the high voltage output cable. Insert the high voltage output cable into the high voltage dry well and secure the threaded collar. Take the other end of the high voltage output cable and connect it with the alligator clamp to the center conductor of the cable under test. Make sure the external safety key has been inserted into the interlock provision and that any other local or workplace safety provisions, including light trees or deadman switches, are enabled. Turn the main power button on. Running a VLF test. We'll use the sample test profile we've created for the 15 kV cable maintenance test. Using the IEEE 400.2 2013 standard. Recheck all connections and safety provisions, including interlock key. Choose your test and authorize high voltage testing before automatic countdown is over. Once the profile is selected, the screen will turn yellow and a 10-second safety countdown will begin. If all safety parameters have been met, begin the high voltage test by pressing Start again. Monitor the results in real time via the display screen. Data will populate after the first full wave cycle has been completed. Abort at any time with Disable button or safety provisions. Test results automatically save to the VLF E-Series with a date and time stamp at the completion of the test. If a USB device is present, test results autosave to both the USB and the VLF. Users also have the option of using the Save As feature to change the date and timestamp to whatever name they want. View, copy, or move results to the E-Link software later. A separate video covers the operation of the E-Link software. Conclusion. This concludes the overview of the VLF E-Series high voltage cable test sets. For more detailed information on usage and maintenance of the VLF E-Series, refer to your user manual. Thank you for choosing HVI and our 3 generations of engineering excellence.